Getting to the moon looks easy on paper. Just point a rocket at it and go, right? Wrong. Every meter of that 400-kilometer journey is a battle against forces that want you dead. From the moment of launch to the moment of landing, 1,000 things can go wrong, and most of them have. The moon has killed spacecraft before. It's killed astronauts in simulations. It's come terrifyingly close to killing them in real missions. This is the story of what it really takes to get a spaceship to the moon, and why it's the hardest thing humanity has ever attempted. Why is getting to the moon so incredibly difficult? Because you're fighting against everything. Gravity wants to pull you back. The vacuum of space wants to crush you from the inside. Radiation wants to cook you. Temperature swings of 300 degrees want to destroy your equipment. And the moon itself, that beautiful, silent world, is covered in razor-sharp dust that wants to tear your spacesuit apart. Every mission is a war against physics itself. The stakes couldn't be higher. In 1967, 3 astronauts died in a fire on the launch pad, killed not in space, but during a simple test. Apollo 13 came within minutes of losing its crew to an explosion 200,000 miles from home. Every astronaut who straps into a rocket knows the statistics. They know that spaceflight is, and always will be, incredibly dangerous. But they go anyway, because some things are worth the risk. In this documentary, we'll follow a spacecraft on its impossible journey to the moon. From the terror of launch to the violence of booster separation. From the silent emptiness of space to the invisible threat of radiation. From the critical engine burns to the nail-biting landing. We'll explore every challenge, every danger, every moment where one mistake means death. It starts here. On a launch pad in Florida, 1,000,000 kilograms of metal and fuel stand ready. The astronauts have said goodbye to their families. They've been strapped into their seats for hours. Below them, 8.8 million pounds of thrust wait to be unleashed. The moment of ignition is pure violence. The engines consume 15 tons of fuel per second. The sound is indescribable, so loud it can kill you if you're too close. The vibration shakes the very ground. And yet, inside the capsule, the astronauts feel surprisingly little. Just a gentle push, then acceleration. About a minute into flight, the rocket hits max Q, maximum dynamic pressure. The atmosphere is still thick, but the speed is enormous. The forces on the vehicle are higher than at any other point in flight. One weld too weak, one material flaw, and the rocket could tear itself apart. 2 minutes in, the solid rocket boosters have done their job. Explosive bolts fire, and the boosters fall away. They'll parachute into the Atlantic to be recovered. The core stage pushes on, its engines still burning. 8 minutes after launch, the core stage has done its job. Empty of fuel, it separates and falls back to Earth. The upper stage takes over, pushing the spacecraft into a parking orbit around Earth. For the first time, silence. They've made it to space. But what if something goes wrong? Every crewed spacecraft has a launch abort system. A small rocket on top of the capsule that can fire, pulling the crew away from a failing booster in milliseconds. The spacecraft has reached Earth orbit, about 200 kilometers up, circling the planet every 90 minutes. This is the first checkpoint. From here, they could still turn back if something's wrong. But everything checks out. Mission Control gives the go. For the next few hours, the crew runs through an exhaustive checklist. Every system is tested, every reading is verified. The engineers on the ground analyze telemetry, looking for anything out of the ordinary. But everything is perfect. Their go for translunar injection. Through the window, Earth is beautiful, more beautiful than any photo can capture. The astronauts know this might be their last view of home for a while. In a few hours, they'll fire the engine that sends them toward the moon. It's a moment of profound emotion for every human who's ever left Earth orbit. Now comes the most critical burn of the mission, translunar injection. The upper stage fires for about 5 minutes, adding enough velocity to escape Earth's gravity and head toward the moon. The acceleration pushes the crew back into their seats. Outside the window, Earth begins to shrink. When the burn is complete, they're on a trajectory that will take them 250,000 miles from home. The precision required for this burn is almost incomprehensible. The engine must fire for exactly the right duration, at exactly the right angle. If it's off by a fraction of a second, they'll miss the moon entirely, either swinging past into deep space or crashing into the surface. The navigation computers calculate every variable, and the crew monitors every reading. One mistake, and they're lost forever. When the engine cuts off, silence returns. The only sounds are the hum of fans and the occasional crackle of the radio. Earth is already visibly smaller, shrinking by the hour. The astronauts are now farther from home than any humans in history. Once they leave Earth's protective magnetic field, the crew enters a dangerous environment: deep space radiation. Cosmic rays from distant supernovae, solar particles from our own sun, they constantly bombard the spacecraft. On Earth, we're protected. Here, there's nothing. Just a few millimeters of aluminum between the crew and cancer-causing radiation. Before they even leave Earth's neighborhood, the spacecraft must pass through the Van Allen belts, two regions of trapped radiation that can be deadly. The biggest radiation danger isn't the constant background, it's the unpredictable. Solar flares can erupt without warning. Modern missions include a storm shelter, a small heavily shielded compartment where the crew can wait out a flare. In deep space, temperature is a constant battle. In direct sunlight, the spacecraft can reach 120 degrees Celsius. In shadow, it can drop to -150. Space isn't empty. It's filled with tiny particles, micrometeoroids, moving at incredible speeds. A grain of sand can carry the energy of a bullet. Beyond the physical dangers, there's the psychological challenge, the isolation, the knowledge that no one can rescue you. They're alone out here, farther from home than anyone in history, and they have to be okay with that. Before they can land, they have to lower their orbit. Another engine burn, another critical maneuver. The landing site comes into view. For Artemis missions, it's near the lunar South Pole where ice lurks in permanent shadow. Now comes powered descent initiation. The lander fires its engines to slow down and begin the drop to the surface. From here, everything is automatic, but the crew monitors every reading, ready to abort. The surface is still 15 kilometers below, rushing up. Landing on the moon is incredibly difficult. Modern landers use terrain relative navigation, cameras that image the surface and identify safe sites. In the final seconds, something dangerous happens. The engine blast kicks up lunar dust. It can blind the cameras and confuse the sensors. Then, touchdown. Probes on the landing leg sense contact. The engine cuts off. Dust settles. Silence returns. For a moment, no one moves. Then the checks begin. Systems nominal. They've done it. They're on the moon. The impossible journey is complete. They've landed. But the challenges aren't over. They've just changed. The lunar surface is one of the most hostile environments in the solar system. No atmosphere means no protection from radiation. Temperature swings of 300 degrees between day and night. And everywhere, there's dust. Lunar dust is unlike anything on Earth. Formed by billions of years of micrometeorite impacts, it's microscopic, razor-sharp, and electrostatically charged. It sticks to everything. On Apollo missions, it wore through spacesuit gloves, clogged equipment, and even caused lunar hay fever in astronauts. Lunar dust is not just a nuisance. It's one of the biggest technical and safety challenges for future moon missions. It's sharp, sticky, and potentially harmful. Why is lunar dust so sticky? Radiation from the sun gives it an electrostatic charge. This causes them to levitate and stick to anything with an opposite charge. Spacesuits on the moon face an impossible task. They have to maintain Earth-normal pressure in a vacuum. They have to allow movement despite that pressure. They have to protect against radiation and micrometeoroids, and they have to keep out dust that's sharp enough to cut through fabric. Engineers are working on solutions. One promising technology uses carbon nanotubes woven into spacesuit fabric to create a field that repels charged dust particles. NASA's Artemis program isn't just about visiting the moon, it's about staying. Future missions will establish a lunar base. They'll learn to use local resources and prepare for Mars. But that means solving new challenges, long-duration life support, and radiation protection. The Gateway will be a space station in lunar orbit, a home base for astronauts, a laboratory for science, and a staging point. It solves some problems while creating others. How to maintain mental health and physical safety while living far from Earth for months. The key to sustainable presence is living off the land. The moon has water ice at its poles, enough to drink and make rocket fuel. In situ resource utilization, ISRU, is the technology that will turn lunar ice into oxygen and hydrogen. Future missions won't bring all their fuel from Earth. Everything we learn on the moon prepares us for Mars. The same challenges, radiation, dust, life support, will be magnified 100-fold. The moon is our training ground, our test bed, our first step toward becoming a multi-planetary species. The challenges we overcome here make everything else possible. Getting a spaceship to the moon is the hardest thing humanity has ever done. The challenges are endless, the risks are real, but we've done it. We've done it before, and we're doing it again. We look at the impossible, and we figure out how to make it possible. We can't forget the cost. Brave men and women have given their lives in this pursuit. They knew the risks, and they went anyway. Their sacrifice reminds us that exploration isn't just about glory, it's about courage, about believing that some things are worth dying for. The next mission is already being planned. New astronauts are training. The journey to the moon will never be easy, but it will always be worth it. Because when we look up at that silver disk in the sky, we know that humans have walked there, and they will walk there again. The journey to the moon is 384,400 kilometers of terror, but it's also 384,400 kilometers of hope, of courage, of human achievement. Every spacecraft that makes the journey carries the dreams of everyone who's ever wondered. The journey is impossible until we do it. Thank you for watching. If this journey inspired you, share it with someone who needs to dream. Comment below. Would you make the journey to the moon, knowing everything that could go wrong?